Hi, and welcome back to Programming for Biologists. Today, we are going to be looking at functions. So, functions are really important because they allow us basically to reuse our code without having to type it all out again. They allow us to use other people's code, and we've done this in libraries a lot. And they also make our code more readable because we might be doing specific operations over and over again, and we know that that's all being done in the same way if it's wrapped inside a function. So we've already used quite a few functions as we've been going through these different sessions. Print, for example, whilst not a function traditionally in Python 2, is a function in Python 3. And we can tell functions because they're normally a text prompt, so like a variable name, in this case a function name, followed by round brackets, and then they normally take some sort of argument. In this case, print takes strings or numbers and then it prints them out. So print is a function and it allows us to print hello. Another function that we have used, maybe we haven't used this in the past, is sum, which, adds everything together as you would expect. So 1 plus 2 plus 3 plus 4 is 10. So we can print the sum of our list here and we get 10. Another function that we might use quite a lot is type, and this allows us to check what the class of an object is. So the type of hello is a string. I mean, we can see that now because they're in inverted commas, but say this was a variable, we could check what type it is, and we would get string back out. We can use type to check anything, so if we run this on print, we can see that print is a function or method. So that's nice, but how do we make our own functions? Now, it might be surprising, but Python by default has no mean function. So if you want to average stuff, you sort of have to do it the old-fashioned way or use a different library. But what we're going to do here is make our own mean function. So we want to basically make it so that when we type mean in brackets and put a list in, that it returns the average of that list. So we can see now we're getting a name error because there is nothing called mean. So the way that we define functions is using this def keyword. So when we're writing a new function, we type def, and then we type the name that we want to give the function. Then we do an open and close bracket, and then a colon. And then anything that's then indented under this becomes part of our function. So now we've created a function called mean, but it doesn't do anything. So we've added pass here, which lets us basically run the function and save it without actually putting anything inside it. So if I was to delete pass, for example, we would get an error because it's basically saying, you've defined a function here, but it doesn't have anything in it, so I don't know what to do with it. Another thing you can do instead of pass is put 3 dots in, and this is basically doing the same thing as pass. Okay, but now if we try and run our mean function, it still doesn't do anything. We get this type error, and it's basically saying mean doesn't actually take any arguments, but you've given it an argument because we haven't set anything inside our parenthesis that tells the function what it's expecting. So it's not expecting anything, and when we give it something, Python raises an error because our function by default now doesn't take anything. So what we need to do is basically define a set of arguments inside of our function header, inside of these brackets, to tell our function what it's going to take in. And we can basically call this whatever we want. So when we're making a function, I think it's best to sort of plan out what we want. What do we want our function to do? Well, if we're going to take an average, we're going to be taking probably a list of numbers. So the first thing we need to do is make our function be able to absorb a list of numbers, and then we want it to return the mean value of that list back to us. So when we're adding arguments to functions, we basically write in the variables that we want them to be called inside of our function. So we're like predefining variables, and these will only be set when we run our function. So here we are setting the variable that we want to have inside our function as list1. So then if we're going to create an average, we need to know the length of that list, because the average is the sum divided by the total number of elements. So we can get the length of the list by using the function length. So len returns the length of a list. And then we can also use sum, which we looked at earlier, to get the sum. And then we can get the mean value, which is the list sum divided by the length of the list. So if we run this, we can redefine our function, and now it has an input, and it will calculate the mean. But we can see when we run this, we don't get anything back. But we're also not getting any errors. So this is progress, but it would be nice if our mean function actually told us what the mean was. So one way we could do this is just get it to print the mean. So now we've updated our function, and I've saved it again to print the mean. You'll notice when you run this, you don't get anything out. And the reason you don't get anything out is because we're just defining the function. You know, we're running this def and this, but we're not actually calling our function. So if we define a list, and then we run mean, it now prints out what the average of our list is. But if we try assigning this mean value to a new variable called list mean, and then try and print the list mean, we can see that it says none. And that's because whilst our function is printing out the mean value, it's not returning the value to our code. And to return values back to our code, basically we need to put in this return statement. So for the last time, we're going to update our mean function. And instead of printing now, it's going to return the mean value. So when we run the code this time, it's not going to print out the mean for us. But hopefully it's returning this value out of the function and storing it in whatever the variable is here. So list mean should now equal the mean of our list, which it does. So that's great. Now, we've obviously written this function in a very wordy way. And the reason we've done that is just to make it easy to understand what each bit's doing. But actually, when we're writing our own code, we might want to write it in a much more simple way. So in fact, we could make this short version of the mean, which we'll call a new function short mean, where we basically still take a list, but then we just get it straight away to return the sum of the list divided by the length of the list. And we can see that our short mean basically gives us exactly the same value as our much longer function. And we can check that they're equal to each other by using this double equals sign from our booleans. And we can see that it's true. Our short mean and our mean do exactly the same thing. Now, obviously, there are functions inside Python that can return a mean for you. And one of the libraries that we use for a lot of maths is called numpy. So numpy is a very powerful package. It has lots of different numeric functions inside it. You can use it for doing lots of array operations and very quickly analyzing large data sets. It's a really good and useful library to learn. And inside of it, it has some basic mathematical functions. So what you can see here is that I'm importing numpy. But I'm doing something a bit different here. I'm saying import numpy as np. What I'm saying is now basically assigning this library to this name np. And this means that when I type np, it's giving me access to the numpy library. And the reason that we do this in code is that we don't want to type numpy every time we want to use an numpy function. We just want to type np. And there's quite a few libraries which have sort of standard shorthand. So pandas, for example, is always imported as pd. Okay, so what we can do is import numpy as np, as we have just done, and we can put numpy dot, and when we do this, you should basically see lots of different functions that are contained inside of numpy, lots of array operations and things, but inside here is median, mean, etc. Standard deviation, which is SDD. And what we can do is use the numpy function mean on our list. We can see this returns exactly the same value. So whilst we didn't need to create this mean, and it's in there, I think it's quite a good example to use just to how we can make short functions. So I think in future lessons, we will probably make lots of our own functions, but they're a good way of compartmentalizing our code. You know, if you had lots of lists to work on, so sort of like list 1, we already have, but maybe we make list 2, which contains a bunch of different numbers. And then also list 3. And now we can use our mean function on list 1, list 2, and list 3. And each time we don't have to type out sum list divided by length list, right? We've made it much shorter, and we can just okay, list 1, how did I write this? Oh, it was just, sorry, list 1 was defined inside of the mean function. Our list was actually called my list. So there we go. And if we print each of these, we can see it's much easier to basically use our function to reuse that little bit of code that we wrote earlier to do something quick. And also it makes our code more readable because we can see that we're just getting the mean for each of these things, especially if we use descriptive names for our functions. Okay, so that is everything for this lesson on functions. Next, we're going to be looking at how we can import data. In the next session, I think we'll just focus on how we can use the standard Python library to import data and read through data. And then in the session after that, we will have a quick look at pandas and how we can use that to import data sets. Okay, so thank you for listening, and I will see you in the next session.